Okay, these problems go with section 6.3. We're dealing with proportions still. We're doing with difference, positive or negative, in the sense that it's an increase or a decrease. So, two types of formulas. The one way that you can do it is that the difference goes over the original amount. Okay, so it's the difference between the two numbers over the original amount, and that's always the setup. Then you can also then do the percent over the 100. Sometimes people have learned it that way. So it's the difference between the two numbers is for a percent increase or decrease. Problem number 2, if a number decreases from 56 to 49, what is the rate of the decrease? So you're looking for a rate. So we'll need to get the information you need. So the difference then, what is the formula you're going to use? Well, it's rate. We're looking for the rate, right? Looking for the rate. So its rate is going to be on the outside. Okay, the proportion over the base. All right. So the proportion, or the part, always think of P as in part, is the difference. Remember, we need that difference number. So we have to subtract these two. So that's 7, and it started at where? 56. So it's always over the difference over the original amount is that setup. That helps you with the P and the B too, to think of it difference, original amount. Original amount's always going to be on the bottom. Where did it start? So it started from 56. So that's going to be on the bottom. And at that point then, it's just a division problem. So 7 divided by 56, do it on your calculator, 0.125. And that's the decimal, but they want the as a percent, so we're going to have to convert that by moving it over 1, 2 spots to the right to make it a percent, so it becomes 12.5%. So when we're doing these, it's the difference over the original amount. That's going to really be the setup, difference over the original amount. Okay, let's look at number 6. So 750 is increased by 60%. Well, I picked this one because increased by 60% means that it's still with the 150. So increased by, so we have the 100% really goes with the 150. And then it's increased, so we have a plus of another 60%. So really we have a 160% increase, because 100% is what it was, and it was increased an additional 60%. So we have then a total increase of 160%. So then we're just looking for our formula. So the proportion is then going to be equal times the rate times the base. Okay? So with 160 then is going to be the rate, and timesing it by the base, it would be the 750. But you notice we have a percent. We need to convert that to a decimal. So we're going to drop that and move it over 2, right? 1.60 times the 750. Okay, just put it on your calculator again. 1200. So we have to convert that to a decimal. And then it's increased by. That by basically means you've got to have that accounted for still. So that's where that 100% comes in. It's what it started with, all of it, plus that additional. So when you're doing these types of problems, if you have a decreased type of a problem, then you would subtract that per percentage, whatever that problem says. So if it's a decrease by 40, so you would take this, subtract 40, so then you would have 60% of the original value. All right? Here we have $46 decreased by 10.5%. I picked this one because it's a two-parter. So as we're setting, as we're setting this up, we have to take all of it. So we have the 100%, and we're going to decrease it by 10.5. And I'm going to convert that right to the decimal right now. So we're subtracting 10.5 off of that. So then we would have 89.5% of the original value, because we took off that 10.5. Okay, so see how that came in there to that. So then we're just back to our rate times the base. Excuse me, instead of equals. So our rate then, change this to a decimal. So it would be 0.895 times the original number, 46. Okay, gives us $41.17 rounded when you do it on your calculator there. Okay, since it's a money problem. All right, let's take another look at this problem number 12 here. I'm going to scoot this up a little bit. Okay, Sunshine Honda sold 112 cars this month. If that is 40% greater than last month, how many cars were sold last month? Okay, so as we're looking at this, we're going to equivalent, what is the key information? Okay, we have 40% greater than last month. Okay, so this is the new total, and that is equal to last month, which was the 100%. Okay, they don't give you a lot of information in the problem, so you have to kind of figure out what you need in order to solve the problem. So you have last month's, which is the 100%. You have the 40% greater, so that's going to give us a 140% increase, and that's going to equal that 112. So how do we set that up into a problem? Well, here we're going to be, we want to find the old base. Okay, so that's going to be over here to the right then, because that's what we're looking for. How many were sold last month? That's we will kind of get a base problem. So we're going to have the proportion, or the part, over the rate. Okay, so this is going to be the part, right? So that's going to be the 112, and it's going to go over 140. Well, 140, I have to convert that back to a decimal in order to do a problem, because I can't divide by a percent. I mean, some calculators will let us do that, but mathematically we need to convert it. Okay, so we subtract or divide then the 112 by the 104, and we're going to get 80, and we're talking about how many cars were sold last month. So again, you have to just kind of work through the steps on these. You have to kind of figure out, okay, last month is your base, 40% greater than that. So you're always going to have 100. If you have all of the items plus or subtract what you're dealing with. It's either going to be greater or you're going to lose some, but you're going to have that base that where you're starting at, in this case, that 100% of last month's total, which we're looking for, because we don't know that. Okay? Let's do a couple more, or let's do one more anyway. Let's take a look at number 16. It's a two-part problem here. Housing prices in the Brighton area of Webster County have increased 37.5% over the price of houses 5 years ago. If $160,000 was the average price 5 years ago, what is the price of the house today? Okay, so again, we've got to have that base. So what is the base? The base is going to be the 100%. And we have an increase of the 37.5%. So then we have a total then of the 137.5% of the total. And this is the old total. Okay, 160,000 is what it was. So we've got to find the new total. So we're just doing a, excuse me, simple proportion problem where we're taking the rate times the base. Okay, the rate then, we're going to have to take that and make it a decimal, so that's going to be 1.375 times, right, the 160. Okay, and again, that's just calculator. So we would get a new total of 220,000. Okay, so again, you're always going to have to deal with that 100% and add or subtract, digging through the problem to find out exactly what you need. This one, though, that has a part B to it. Economists predict that over the next year, housing prices will drop by 4% in the area. Based on your answer in part A, which is this, what will be the average price of the house this year? Well, again, so now we're back to the 100%. We have 100% of something. It's going to go down 4%. So that new total then is going to be 96% of what it was, because it went down the 4. We'll drop by 4, minus 4. Okay? So So that is going to be our new number we're going to be multiplying. And it's the same type of problem we did before. We're just looking for a new proportion or new rate, so it's just rate times the base. So 96%, move that decimal over to 0.986, 96 times the answer we had up here. Remember, was that 220? Yep. Gotta get on my zeros first. Okay, now we're just multiplying. Again, it's just on a calculator, so we plug that in, and we would get $211,200. Okay, have fun with these.